Welcome back, ladies and gentlemen. If this is your first video here, this is the second video in a series of 3 videos to talk about solving systems of nonlinear equations. So finding out when some nonlinear functions or equations actually intersect. And we're going to use algebra to figure this out. So we have in front of us here is an ellipse. This is an ellipse. It's doesn't look like the standard ellipse formula with center at 0. In fact, you'd have to do some manipulation to make that look like so. And below it, we have a circle with radius 2. And we're going to find out algebraically when they intersect. Now, it's true that I do have a picture of that to the right, but you're not going to have the picture afforded to you during the exam or the homework. So the picture shows the intersection points, and I will do so algebraically. Now, this technique is going to be called the elimination technique. Now, the other videos are going to concern themselves with substitution and the transitive property. The substitution is going to be used when one variable can be easily isolated. The other transitive property will be used when we have 2 variables isolated and they're the same variables. But in this case, we're going to use elimination, and what I said in the other video is we'll use elimination when we have powers of the same degree, variables of the same power or the same degree. Now in this case, you can see that x squareds are the same power and y squareds are the same power. So what I can do is just kind of put a line underneath and either add or subtract straight down these columns and see if I can eliminate a variable and solve for the other variable. And in this case, I can. Just because I have a match with these y squareds here, I can subtract all down 3 columns. And if I go 4x squared minus 1x squared, I get 3x squared. Y squared minus y squared is 0, so that simplifies to 0, or cancels as many would say. And 16 minus 4 is 12. Dividing both sides by 3, using inverse operations to get the x squared by itself, x squared is equal to 4. Then I take the square root of both sides, and this gives me x is equal to plus or minus 2. You got to remember when you take the square root, you got to consider that the answer would be either positive or negative. So I guess what I have to do now is take that plus or minus 2 and consider 2 situations. One situation when x is equal to 2, and another situation when x is equal to negative 2. I'm going to, now, if you actually kind of just quickly for a moment, can you look over here on the picture? You do see that our intersection point is at x equals 2 and negative 2. Again, the picture won't be there for you, but it is kind of nice to see that we're kind of on the right track here. All right, so now x is equal to 2. I'm going to either plug it in the top or bottom equation, and I'd probably be better off plugging it into the bottom equation. So I'm now going to plug in my 2 in for the x, quantity squared, plus y squared is equal to 4. Now I have 4 plus y squared is equal to 4, and I subtract 4 from both sides. Y squared is equal to 0, taking the square root of 0, which is 0, and so my y is equal to 0. So the answer is 2, 0, which also happens to be that point right there. Now if I plug in negative 2 quantity squared, and you can just, well, shoot, look, it's the same thing. 4 y squared equals 4, y squared equals 0, and then y is equal to 0. So there you have a situation where you have the 2 answers, negative 2, 0, and 2, 0, and those are my 2 intersections of these nonlinear equations, one being a circle and the other being one being a circle and the other being a parabola. Now, for our last example, we are going to move to 2 different hyperbolas here. These hyperbolas are both with y-intercepts, and you can see from the answers here, we're going to have 4 distinct answers, but let's just assume that the picture was not here, and let's do some solving, okay? So what I'm going to do in this problem is I am going to see if I can get some elimination here, if I can see some variables go away. And I guess what I want to do is I want to get the y squareds to cancel out and solve for x. So what I'm going to do is instead of just adding or subtracting, because the variables wouldn't actually go away, I'm going to keep the top equation exactly the same. But this bottom equation, I'm going to multiply that bottom equation by negative 2. Now the reason why I went with negative 2 instead of just 2, you'll see in just a moment, and from my years of teaching math, I'm going to give you a little coaching advice here. you're a lot better at adding than you are at subtracting. So if I multiply by -2, this gives me -2x squared. This gives me a positive 2y squared. So you'll note these will just simplify just by adding them. And this is going to give me a -10. So if I just add straight down these columns here, now I have 1x squared. These make 0. And this here makes a total of 16. Well, take the square root of x squared. So square root both sides. So x is equal to plus or minus 4. So now I have two situations. I have a situation where x is equal to 4, and I have a situation where x is equal to -4. So now I'm going to check these situations and see what my answers for y is. I should plug this 4 and this -4 back into one of these equations up here. Now, should I use the top equation or the bottom equation? It's probably best to use the bottom equation. Even though it has the same number of negatives as the top equation, the numbers are a little smaller. So now I'm going to plug my 4 into the square of the x squared and subtract the y squared from it and set that equal to 5. So now I have 16 minus y squared is equal to 5. Subtract the 16 from both sides, and what I get is a -11. Divide both sides by -1, and now I have y squared is equal to 11. Take the square root of both sides, I get an answer of y is equal to plus or minus the square root of 11. So if x is equal to 4, I have two answers, 4 and square root of 11, and I also have 4 and negative square root of 11. So which two dots did I just find? I just found this dot here, and I found this dot here. These two dots right there and there. So there's 4 square root of 11 and 4 negative square root of 11. These are my two dots of the problem. So, cool, I found 2 of my 4 points. Again, without the picture, you never would have known that there were 4 total answers here. But let's keep going here. I'm going to have x equals -4. I'm going to plug that into the equation. -4 squared minus y squared is equal to 5. And, well, already one step into the problem, and I see I'm going to get exactly the same answers. See how these are exactly the same because the square of a negative is the same thing as the square of a positive. So if I keep going, I'm going to get my answer of y is equal to plus or minus square root of 11. So for -4, I have a square root of 11, and for a -4, I have negative square root of 11. And so that gives me this point and this point. So those are my 4 answers. 4 plus or minus square root of 11, and -4 plus or minus the square root of 11. So again, you're going to get a lot more of these in your homework, and just identify when you see x squareds and y squareds in the problem. You can probably do some kind of elimination step to get one of these variables by themselves and figure out where they intersect. Well, thank you very much for watching. Stay tuned for part 3, or make sure to watch the other parts of these videos if you went out of order for solving non-linear equations. Thank you very much.